Hello students, we are now going to look at initial velocity versus ballistic height. It's very similar to the ballistic pendulum here as far as the things that we're going to do. Just going to go in and you'll see what we need to do. We need the, we're going to use the video techniques from the 15 mini launcher ballistic pendulum to develop a relationship between the initial velocity of the ball and the height of the ballistic pendulum. We're going to use the first click, the second click, and the third click to actually do this. So we're going to find our initial velocity for the first click, and then we're going to find the initial velocity for the third click. We're going to interpolate between those measured points utilizing the template that is given. Then we're going to find the equation of the line. After we find the equation of the line, we're going to find the height of the second click. And then we're going to form a hypothesis based on our interpolated data, and we want to verify our hypothesis. So that's pretty much what we're going to do. The first thing that we need to do is we need to go to Dropbox, of course, and pull those down. So just go back to Dropbox and go to Files, and of course it's under my folder here, Brass Eric, and it should be yours, your folder. So we have initial velocity versus height, and you'll see that I have 3 videos plus this ballistic height template. Now you'll see that I have quite a bit of stuff in here, and it's just from multiple experiments. And so if I want to, I could just go ahead and delete those, which I might do later. And you'll notice that I have some information inside of this template. So what I want to do is I'm just going to delete the information from this template, and then we'll go ahead and acquire we'll go ahead and set up our experiments and acquire the data. So let's see if this will come open for us. So right now it just opened up the same thing that I had before. So I'll just try to open this again, and Microsoft Excel does this. Okay, so I have my first compression length. This is the data that I'm just going to eliminate. Everything else is being calculated for me, so I'm just going to clear that out. Then we have our second compression. Same here. It's just some more data that we're all going to acquire, and I am just going to clear that out. And then we have our third compression here, and this is just some data that I need to clear out as well. And you'll notice that we have an interpolation page as well. And so this is the template that we're going to use. So the first thing we need to do is we need to pull down those videos, the first click and the second click and the third click, which I actually already have inside of video physics, which is great. And so you'll see that I have the first compression, Brass Eric, and you'll notice that I have my origin and scale. Look at where I have the origin set. I actually have the origin set at the first anchor bolt right here. So you could do the same thing, or you could choose a different location if it's more strategic for you to do so. And then I actually have my scale between 30 and 40, okay, and it's 10 centimeters still. I have 278 pixels at 10 centimeters. And I'll just close that down. And of course you want to take a snapshot because you want to open that and notice the name, First Compression Brass Eric. Make sure you put that there. And if you look, I have points already here, okay? So I basically started with the first position. I let the template, not the template, but let me just start this up, okay? So if I go back, I fired once, I took a point, and then I let the pendulum rise, and then I took another point here. Okay, and I did that 11 times, I believe. So if I just let this play, you would see the same thing. So that's black and white for a different set of data, and then I'm changing the color for different sets of data. And that's all you really have to do. And you'll notice that the video is very short. Once this video is done, what I'm going to do is I'm going to show you my graph here. And this is what I have. I have this for the X, but we're not concerned with the X. We're actually just concerned with the Y. And so we're going from this location to this location, and we're primarily concerned with the displacement in the Y. And we have one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data sets. So make sure you guys upload this video with points to your Dropbox. Right now, I'm just going to go to data file. But again, make sure you upload to your video with points to your Dropbox folder. So data file, I'm going to go ahead and select that. I'm going to open this in graphical, of course. So once I open it in graphical, I'm going to change that over to a table just like normal by selecting on the format button here, and I'm going to choose table. And we have our table there, so let me just go ahead and share this with Microsoft Excel by opening in Excel. So it shouldn't be a big problem. It's in right now. I can say convert and edit. So I want to convert and edit. And of course, I want to put this into the appropriate Dropbox folder. So of course, I'm going to go back to Brass Eric. And since we're working with initial velocity versus height, go to number 16, and you'll see that I have a variety of them already. So I already have one first compression Brass Eric. I'm just going to go ahead and put the data there. And we are only concerned, according to the theory, and let me see if I can get to the theory real quick. I should be able to with no problem. According to the theory, which is right here, the only thing that we're going to need is this. We'll need the mass of the ball, mass of the tube, the mass of the ball, and we'll need 2 times g. All we need is y sub f. We know the mass of the ball is 16 grams. We know the mass of the tube is 118 grams, and we just need y sub f. So let's go back here. If you look at the Excel spreadsheet, notice our data sets. We have time, we have x, we have y, we have x velocity. We don't need time or the x position. We don't need the x velocity or the y velocity. All we need is the y position. So we have a 0 here, and what constitutes it as a 0? Well, we have 1, 2, 3 zeros here, and we just have 2 right here. So we have 0, we have our initial position, final position, initial, final. And you want to check these. Initial, final, 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 initial, final. So we're just going to take this data and we're going to put it into our template. So I'm just going to copy, going to go back to our ballistic height. Ballistic height versus initial velocity document, and it is in your Dropbox folder. And now this is for the first compression link. You may or may not be able to see this down here, but it's for our first compression link. So go to that tab and then just paste, and you'll notice that things are pasting in for us. Okay, and so we have all of our displacements calculated. We have our average displacement here. You shouldn't have any zeros and you should not have any negative numbers in this y displacement column. You can have them over here. These are just zeros. And our initial velocity is coming out to be 2.9. I'm going to go ahead and acquire the data for, in fact, I actually have the data already saved in this folder. And so you want to acquire the data for each one of those videos in the same manner. And let me go up here to initial velocity. And you'll see that I have two first compressions right now. I just want to go to the second one right here. So this is data that I already have. I'm expecting you to know how to do this by now. And you'll see that I have everything cleared up. 0, 9, 0, 9. The data is good. 0, 9. Make sure your data is good. I'm going to copy that, go back to the template, which is right here. I'm going to paste that one in. And that's going to go into the next tab. You'll see that we have the first compression here. Let's just go to the second compression right here. And I'm going to paste. And you'll notice that everything is coming out nicely. I have 3.6. And the next one we're going to do is the third compression. So of course I have that information here. And you can do yours the same way. You can collect all the data first, and then you can go through making sure that the data is conditioned properly or that it has the right format, and then just copy and paste into the template. And so now I am going to just copy this data, and I am going to go back into the template. And once I go back into the template, I'm just going to go to the third compression tab here. Once I'm under the third compression tab, all we have to do is just paste in just like we've been doing. And you'll see that the data is coming out positive for the y displacements. And each of them look consistent. And we have an average y displacement and an initial velocity here. For the third click, it's 5.4. And of course, this is just already worked out for us here. We have our interpolation taken care of. We have our initial velocity, our ballistic height, and we have our measured velocity for the predicted ballistic height. And when I say that, now this you may not have. So your formula is going to be different. You actually need to put a different formula in right here. So you'll see something that says insert your formula here. But I'm talking about this one right here. So say this cell needs to equal to 0.006 times x. X in this particular case happens to be what's on the x-axis, and I don't have it written in here for whatever reason, but it is the ballistic height. So if you guys look over here, it is actually the ballistic height. The y, then you guys make sure you label yours properly. Actually, no, it's the initial velocity. And the y is the ballistic height. So let me just move this down. And so we have our measured initial velocity at the second click. This is the predicted ballistic height, and our measured ballistic height is here. And we have a percent difference of 8.02. So that will conclude this particular experiment. Just make sure you upload everything, have all of your documentation there, and that'll be awesome.